Two and a Half Admins, episode 172. I'm Joe.
I'm Jim.
And I'm Allan.
And here we are again. Let's do some news then. And the one topic that everyone wants to hear from you two about are these ZFS bugs that we've had recently.
Yeah, this one started just before the US Thanksgiving holiday with some reports that using the new block cloning feature in OpenZFS 2.2 was causing some files to not copy properly. After some digging, it turned out it wasn't block cloning that was at fault at all. It was the default change in behavior in core utils was exposing a different bug in ZFS. What was interesting to see from the kind of furor around this particular issue was lots of people saying the Linux devs have gone crazy and they're not doing a good job with ZFS, or it should be more like the original Sun people or the FreeBSD people and so on. But as it turns out, this bug looks to date back to possibly well into the original Sun version of ZFS. That this bug is from the HOLEy Sun source code, not the later Illumos or FreeBSD or Linux versions of ZFS.
So why have we only found out about it now then?
Because it's very difficult to hit.
Yeah.
It's a race condition, essentially. And the thing about race conditions is you have to win, or if you prefer, lose a race to hit it. And this was a very difficult race to win or lose, whichever way you want to look at it. Allan is probably a better fit than I am to describe exactly what kind of race you have to lose to get nailed by the bug, since he's actually looked at the code. Allan?
Yeah, so what happens is when you're modifying a file, but at the same time, another process maybe has that file open and it does what's called an L-seek. So it asks the operating system, I'm at this offset in the file. Tell me the next time that there's actually data in this file, or the next time that there's a hole in this file, right? So if you have a sparse file where a chunk of the file isn't ever actually been written and it's just empty space, instead of having to write all zeros to the disk, you can create a sparse file where the file system knows, all right, this chunk of the file is actually full of nothing. If you try to read it, I'll give you zeros, but I won't actually have to write it all to disk.
So like a virtual machine image is a classic example of that, right?
Exactly.
Yeah. And so if you're using CP on that virtual machine image, then having a CP that will go through and be like, all right, I've copied that much of the file. Now tell me the next time that there's a hole or the next time that there's data, and I will use that information to keep the sparseness. So if I make a copy of that VM image, I don't actually expand all that sparse space into zeros, making the file bigger, or even just waste the time reading and writing the chunks of the file that are blank. And so in Core Utils 9.2, they switched some of the defaults to do more of that by default, instead of you having to give extra flags to the CP command to make it actually try to do that. The problem in ZFS comes from if somebody is just in the process of writing to the file, as you ask, is this next chunk populated or not? If you've just written the data, the ZFS will know that data is dirty, meaning it exists in memory, but it's not been written to the disk yet. And ZFS will give the right answer. But if ZFS has had the data just long enough that it started writing it out to disk, and so the metadata is written out, so it's marked as clean now, but the actual data hasn't been persisted yet, then that check could, because it only checked one of those two conditions, could say that that chunk of the file wasn't populated yet when it was, or it would give the wrong data because it hadn't actually written the right data to disk yet. And this would result in when you copy this file during that tiny window where somebody's modifying it and ZFS is syncing it out as you're trying to seek through the file, it could cause it to copy the wrong data or make a hole where there shouldn't have been a hole but actually been data, or vice versa. And so it was found that when compiling a Go application, that when it was doing this optimized copying, it was missing part of the data that had just been written because it hadn't actually been written yet, and was causing corrupt files or files full of zeros. And so when you then tried to use the thing you just compiled, it wouldn't work because it was full of zeros. And it turns out that the block cloning feature could have slightly widened the window for this to make it a little bit easier to hit, but it was not actually a bug in the block cloning feature.
And the big change, from what I understand, is the fact that hole preservation is now on by default with core utils in Linux, where you used to have to issue a special flag to CP. So you're getting a lot more of these kinds of copy operations being made just sort of casually now, which makes it easier to hit the bug. It's also kind of interesting. This is, I think, the third data corruption bug that I have not had an issue with because I don't use sparse files. In theory, I use sparse files, obviously, since everything I do is VMs on ZFS. But because I've always stuck with QEMU's QCal2 format, from the file system's perspective, it isn't sparse. So these hole detection bugs have not nailed me. And I'm starting to pat myself on the back a little bit for avoiding overuse of sparse files, because it's starting to seem a little dangerous, honestly.
In this case, it's mostly the mechanism for doing it. Part of the problem is, in order to definitely give you the right answer, ZFS would have to make you wait until it synced out all the pending data and then check if that chunk of the file was a hole or not. But doing that would make any of those hole checking operations extremely slow. And, there was a desire to not have applications trying to do that get terribly, terribly slow. But it does seem that this bug has existed for a very long time. It's been confirmed at least far enough back for ZFS on Linux 0.6.5 or something like that. But the fact that it was also found in Illumos suggests that it's been around way, way back into the history of ZFS and not really been hitting people.
And so does ZFS know that the data is corrupt then?
No, because it's not actually ZFS technically corrupting the data as much as CP deciding not to copy a chunk of the file because the VFS layer told it that chunk of the file doesn't contain any data. CP told ZFS, write a hole, not the data. And so when you then ask for that chunk and ZFS is like, here's a hole, ZFS is like, that's what's supposed to be there because that's what you told me to put there.
You have to remember, Joe, although it's a file system, the file system is not what actually runs the copy operation. You don't tell ZFS, copy this file to there. When you interact with ZFS, you're doing so on a much lower level. It's actually core utils doing the copying. So you've got an extra layer of complexity there for things to go wrong, where core utils cannot understand things internal to ZFS and vice versa. If your file system had its own file copy operation, then you wouldn't really be looking for this kind of a bug to happen, but that's just not really how file systems and core utilities tend to get developed.
Although technically, that's really what block cloning is CP telling, hey, ZFS, could you copy this for me instead of me copying it manually and rewriting it? And internally, ZFS can do that without actually having to make a copy of the data by just ref-linking it instead. And so that's kind of what core utils was trying to go for by using these newer routines. But like Jim said, instead of relying on the file system to do the magic here, it was trying to do the magic itself. And that's where the problem came from.
And what about snapshots then? Would they have helped here?
Yes.
The file that was damaged would be when you manually CP'd a file. The original file wouldn't have been damaged.
Yes, but more to Joe's point, yes, snapshots would help, because even if it was an issue of like you corrupted your last good copy of a file, or you CP'd it and then, deleted the original, whatever, if you still had the original in a snapshot, yes, it would still be there and it would be fine. It seems like there's still some confusion here. Make sure everybody's completely on board. Once you understand that core utils is what's actually doing the copying block by block and not ZFS, now you can understand that when core utils says, hey, I want to copy this block from here to here, the issue is that if ZFS had that block down as a whole, but now it's got dirty data that's ready to be written out to that whole, there is a condition in which if you hit it at exactly the right time, ZFS can tell core utils, hey, that's just a hole, you're good, where really there's dirty data there that should have filled that hole, but it didn't tell core utils about that. It told core utils about the hole that was there just an instant ago. So when core utils actually makes the new copy, as far as ZFS is concerned, the new copy is perfect because core utils put exactly the blocks where they wanted and ZFS put the blocks down that core utils gave it. So for ZFS's concern, yeah, everything absolutely matches its checksums because core utils said put a hole here and ZFS put a hole there and, well, it's a hole. Everything checks out. There you go.
That's the really complicated thing with this one is that CP is not actually trying to read that chunk of the data. It's doing this lseek and saying, is this a hole? Or tell me where the next hole starts. And ZFS gave it the wrong answer. If CP had just tried to read the block, ZFS would have done the right thing and gave it the dirty data.
Right.
But because CP seek-holed and got told it was a hole, it never tried to read the data. And that's why this bug has never been found before, because if you actually read the file, you would get the right information. But now that CP instead tries to seek-hole and decides not to read that chunk because it's a hole, it ended up with some missing chunks in files.
So where are we now with this then? Is it fully patched?
It's fixed in 2.2 and 2.1.14, and we've sent a patch to Ubuntu to get it into 0.8, the version of ZFS that ships in Ubuntu 20.04. On the mailing list, Rob Norris from Clara has posted versions of the patch all the way back to 0.6. So no matter what version of ZFS you're using, there is an official patch you can use to get around this bug.
So on Ubuntu 22.04, I'm fine then?
Once Ubuntu ships an update for this, I don't know how their schedule goes for having an errata. But the official ZFS 2.1.14 is fixed, but Ubuntu 22.04 ships 2.1.5, plus whatever patches Ubuntu applies to it.
So we can't tell you for sure when the fix is going to hit Ubuntu because that's really up to Canonical's maintainers. Right now, we're only showing 2.2.1 in Noble, and 2.2.2 is the version you're going to be looking for to actually fix the race condition. 2.2.1 was when they temporarily just disabled the block cloning, hoping that would mitigate it a little bit. However, for other Linux distributions like Arch or Gentoo, you should be able to get a fix in much quicker because they tend to track upstream source a lot more closely. Now that brings us to a better question. I suspect that the majority of the people in the world right now who are actually running OpenZFS 2.2 in production are probably doing it on FreeBSD. Allan, what do FreeBSD users need to do to get the patch applied?
So the errata notice 2316 went out. So as long as you're running FreeBSD 14 P1, 13.2 P6, or 12.4 P8, your system is already patched. So if you just run FreeBSD update, fetch, install, it will install the fix and then just reboot, and you're now running a kernel that has the fixed version of ZFS.
So for all of you folks out there on FreeBSD who have not yet run FreeBSD update, install, fetch, and rebooted, you might want to get on that.
This condition is relatively hard to hit, but it is definitely worth having the fixes. There are also some other errata notices that went out around the same time. There's one that makes sure that the magic.zfs/snapshot directory is accessible over NFS, and another one to make sure if you have a very large amount of RAM, that ZFS doesn't consume a lot of CPU running the arc prune thread trying to release memory. And both of those will also improve your ZFS experience on FreeBSD.
I would like to point out that, yes, I agree with Allan. This bug is very hard to hit. With that said, it's a data corruption bug, which is the worst. And even worse than that, it's a data corruption bug in ZFS, which is where those of us in the know go to get the hell away from data corruption, which is why I'm really trying to stress, to you FreeBSD folks who actually can go ahead and get this fixed immediately, you should go ahead and do it. Don't wait. Don't forget. Don't let uptime rack up forever and be proud of it when you've got a potential data corruption bug lurking in your file system.
Yeah, and there are a bunch of other important errata notices you need to apply anyway, so even if you're not using ZFS, you should still keep your version of FreeBSD up to date.
Okay, this episode is sponsored by Automox. Go to automox.com. AI-powered modern IT automation is here. Save time, eliminate risk, and automate the patching, configuration, and control of all your Windows, macOS, and Linux endpoints with Automox. Learn more at automox.com. That's AUTOMOX.com. Let's do some free consulting then, but first just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember that for various amounts on Patreon, you can get an ad-free feed of either just this show or all the shows in the Late Night Linux family. And if you want to send in your questions for Jim and Allan or your feedback, you can email show@2.5admins.com. And do send in your questions. And as I always say, ideally not a huge long essay. Another perk of being a patron is you get to skip the queue, which is what David has done. He writes, I would love to hear any tips you may have for managing a combination of 40-plus physical and virtual servers.
Apparently, one of the patron perks is also to hear Joe's pleas about how to ask questions before he even makes them. It actually would have been better if this one was a little bit longer, but I'm guessing David's just kind of hoping for a shotgun approach and maybe there'll be something new. It's probably not going to come as any surprise that the very first answer of mine is going to be a full court press for ZFS underneath everything. And the reason for that is twofold. Yeah, the checksumming and all the other on-disk anti-corruption features are fantastic, and I never want to do without them again. But the biggest thing is the replication, man. If you've got to manage a grab bag of 40 plus physical and virtual servers, well, you really want to have a single way that works to back all of them up. And you want it to be reliable, and you want it to be efficient, and you want it to be easy to monitor. And there's just nothing else that hangs with ZFS replication for that. If you get ZFS underneath all of those physical and virtual servers, you can replicate all of them the same way to the same target or targets to back them up. And I wouldn't even dream of going back to the old school and having, individual applications that need to be backed up different ways. Different operating systems need backed up different ways. They need different types of targets. The restore procedures are different. Get rid of all that. Standardize all of your disaster recovery. And at that point, your disasters stop looking like disasters, because that's the thing. If you can recover from it rapidly, how disastrous was it really?
Yeah, I think the biggest things I would say are golden images are your friend. And keep the physical machines as just warehouses of applications, whether that's using either containers like jails on BSD or LXD or something on Linux, or VMs. So the host operating system is nothing more than the stuff to manage the VMs or the containers, and everything lives in some kind of box, whether that's a VM or a container or jail or whatever, because it also means that I need to take, machine 7 down to replace the hard drive or put in more RAM or whatever. So I can use ZFS replication to pick up all of those things, whether they're VMs or containers or whatever, and move them to some other box. So I can now take this one down, work on it, bring it back up, and move applications back. All of using ZFS replication to move stuff around. It means that no longer do you have to worry about scheduled maintenance. You can have that maintenance be just a couple of seconds, right? If you snapshot your VM and replicate it across while the VM's still running, everything's happening, and once it's done, you can replicate just what's changed in the time it took to copy the VM. If the VM's huge, it could take hours. And then you get that delta down to almost nothing, and you stop the VM, sync the last little bit, start the VM on the other side, and now it's cleared off. And faster than the switch can recognize that the MAC address moved, you're back up and running, nobody really noticed, and you've cleared load off that machine, so now you can upgrade the OS. And so using this simple procedure, you can upgrade all 40 of your machines without having to take any of the workloads offline.
Or even just reboot for new kernels, potentially.
Exactly. I mean, like if you're applying the ZFS patches we were talking about earlier in the episode. And then to the same degree, the idea of golden images. To kind of second what Jim said, if you can use ZFS for the boot disk as well, then you can use the boot environments feature either natively on FreeBSD or with ZFS boot menu on Linux or whatever. And that means that when it's time to upgrade, you just install the next golden image and boot into it. And if it doesn't work, you can boot back to the other one. By using ZFS datasets, you can separate out the configuration from the operating system and make sure that your configuration persists even if you change the version of your operating system. And it means you now have fail-proof upgrades. And again, because you kept all the applications in some kind of box, a VM or a container or whatever, none of that can break. And then you now have all your machines that are all exactly identical except for the host name and the IP address, and everything just works.
And the other thing is, the actual machines don't need to be anything vaguely like identical, because wrapping all of your workloads in virtual machines or containers kind of nerfs a lot of the issues that you can sometimes have otherwise with hardware. The other thing I'd like to mention about boot environments, Allan talked about if you can get the actual host to boot from ZFS itself, whether that be, FreeBSD does that by default, or whether you've done a ZFS boot menu install on a Linux distro. The other nice thing about that is that means that you can back up the entire system, the host, all the virtual machines or containers, everything in a single replication operation. And if and when you need to restore, let's say that, God was having a cranky day and a lightning bolt literally smote your server from the heavens, and you're sitting there with a brand new server and your backups and going, okay, how do I get back in operation again? If you were backing up the entire host with replication from a, ZFS en route, you don't even have to install the OS to restore. You can literally just boot into a live environment. You drop like the first gig onto disk, for the boot partition. And then you just create your pool and replicate it straight in from backup.
At my previous company, this was literally our custom installer would boot a FreeBSD live CD, partition the disk, create an empty pool, and then wget a golden image and pipe it into ZFS receive. And that way, every single machine we installed was exactly the same perfect image, and all it got was a hostname and an IP address and a reboot. And that was an installed machine.
We probably should talk about at least one thing that isn't literally ZFS in answer to David's question about tips for managing a combo of servers. And the big thing that we have not talked about, because we really geeked out about disaster recovery, but the other thing that you really, really need, and you start talking about, several tens of systems, you need automated monitoring. You shouldn't be relying on users to tell you that a server is down or an application's not running. You should actually know while they're still wondering if it's broken, because while they're looking at their screen going, that didn't do the thing that I thought it should, ideally your phone is blown up in your pocket and told you this is absolutely for a fact wrong. And instead of the users calling you and complaining because things have been broken for 9 hours and they just sort of sat around and now they're angry because it's been 9 hours, despite the fact this is the first time your phone rang. No. Instead, your phone blows up in your pocket while your users are still trying to figure out, is it broken? You call them and say, hey, it looks like this is broken. And they go, oh, wow, yeah. And you say, it'll be up in 5 minutes. And your users are like, I'm really glad I pay that person every month to keep on top of my stuff.
Yeah, or it even just means that if they call and be like, the internet is down, or something equally vague, that you can look at the monitor and be like, oh, I see what's going on here, instead of groveling around trying to figure out, is it the ISP that's down? Is it a router that's not working? Is the Wi-Fi just out? You know exactly what went wrong as soon as they're complaining, instead of having to play detective for an hour and invariably always, for some reason, looking in the wrong place to start.
Yeah, this stuff seems like a waste of time when you manage, let's just say, 10 or fewer systems. But at some point, once you get into the tens, automated monitoring just becomes an absolute necessity. There comes a point where, like, if you're a managed service provider like I am, you literally cannot scale further without doing something with automated monitoring, so that rather than every single problem being a complete dumpster fire, because by the time your users tell you about it, they're already insanely angry. Let's be honest, we all know users. It's what they do. Instead of that, like, you know exactly what the problems are and you can organize your time and deal with them before they're giant dumpster fires, and you're running around as inefficiently as possible trying to answer questions to irate users rather than actually fixing the problem that will make them not be irate anymore. So anyway, now that we've talked about all this, there are plenty of different monitoring and management solutions out there. Long-term listeners of the show know that my favorite by far is Nagios. It's open source. I like the community edition. The enterprise edition is also fine, but again, I'm into the community. It's very command line driven in the sense that when you do configuration, you're not really like doing a whole bunch of clicking around in the web interface. You're hitting the command line and you're setting up, definition files for your hosts. And you're either using or creating plugins that monitor specific things in the specific ways that you want to. And again, ideally, you want to be looking at higher levels rather than lower levels. It's not like a software development debugger. It's a problem notifier. So rather than looking for a problem on the absolute lowest level, like, is this file system available? Well, if what you really want to know is, can my users get files from this file system, then rather than checking to see if it's mounted, maybe actually, write a plugin that interacts with it a little bit. Maybe that reads a file, maybe that saves another file in a temporary directory and checks to make sure both of those operations actually succeeded. That way, you know for a fact if your plugin has not raised an alarm, your users can get to the file server and they can actually do what they need to do with it. Same thing for, any mission critical applications you have. You should absolutely consider if there are any pre-made plugins for Nagios for that application, use them. If there aren't, it's really not that hard to write your own and make sure that they're interacting with your systems the same way that your users are, to let you know about breaks the same way that your users would, only quicker.
Yeah. Other thing I would say is, once you have more servers than you have fingers, they are cattle, not pets. so they don't get cutesy names.
Absolutely.
It should be like function and number, and that's it. Like, you can't go naming them after planets or starships or elements or whatever. Once you have more than you have fingers, you need a scheme, because otherwise you're just going to hate yourself. It's like, the server Sierra, that runs which services again? Whereas if it's Compute 07 and that runs the container Web 03, that's the web server on that particular hardware, and we can go find it and fix it.
I've got to confirm that and back it up super enthusiastically, what Allan is saying about nomenclature. The cute names are terrible. Functional names are great. I have gotten hired into more than one mid-market environment as a consultant and found the cutesy names, Roman gods, Norse gods, planets, whatever. Planets and Roman gods, same thing, but you get the idea. And every time something breaks, then you see a bunch of developers and admins running around like chickens with their heads cut off. And, they're talking about which server does what and confused about which server does what. And, should I be looking at, Trillion, or should I be looking at Zaphod for that? And I'm just like, for the love of God, man, your VM hosts, they're prod 0, HS 0 for hot spare, and DR 0 for disaster recovery. Increment the numbers if you need more than one host. For your VMs, again, they should be named after what they do. If you've got a database server, well, that's going to be DB0. If you've got an application server you install lots of applications on, that one's App0 and App1 and App2. If there's a specific application that needs its own dedicated VM or VM cluster to run, like an enterprise resource planning application, well, then you got ERP-DB and ERP-app and, on down the line. It shouldn't take a month for a new hire just to figure out what the hell does what. Ideally, you want to have an environment that if you hire a seasoned veteran into your stack to work on this system, they should be able to look at it and on their first day have a really good idea of which things do what and be able to draw a flowchart that's relatively accurate just from looking at a list of your server names.
And it gets back to the monitoring thing. When you get the notification from your monitoring, the amount of it that fits in the display on your phone's home screen should be enough for you to know what's going on. It's the host name. If it says host name is down, I'm like, okay, that's that machine. It affects this, that, and the other service. I know what's happening now. I know whether I need to look at this right now, or if we can wait 10 minutes, or if I don't care.
Your physical hosts, they need physical labels that match their name, that are prominent, that you can find.
On the front and the back.
Yes. Now, the reason for that is you might not need those labels. If you have a small enough outfit with the right crew, maybe you've got like an entire team that doesn't need those labels because they all know which one's prod 0 and which one's HS 0 and, yada, yada, yada on down the line. However, there may come a day that none of your key players are in the office and they can't get in the office in time. And now you have to walk some random rank and file employee through changing a drive in a server. Won't both you and that employee feel so much better when you can tell them the exact name of it that's right there on a big sticker on the front that you can't really get wrong as long as you can read? Even if it's not your employees outside the IT department, you may need to hire a mercenary in. You may be bringing somebody in for just one day, and you definitely want that person who's in there for just one day to be able to go to the right system and do the right thing rather than performing some maintenance procedure on the wrong server that at best wasn't necessary and at worst might destroy it.
Doesn't that extend to client machines and routers and switches and APs and everything? Like, shouldn't they all be labeled?
Yeah, that's a very good point, especially when you've got small business sites. But really, honestly, anywhere, everything in the network DMARC should be labeled. There should be a sticker on everything that says what it is. So when you've got somebody in there and you say, hey, I need you to see if some light is blinking on the router, they shouldn't need to be an IT professional because there should be a big sticker that says this thing over here, that's the router. And the next time that, that client's ISP screws up and you need to have somebody reboot the router, you'll be very happy when you don't need to spend 15 minutes trying to describe what a router might look like when you can't even remember for certain which brand they had at that particular location.
Yeah, and make sure they're rebooting the router, not the AP that's on the wall, because the thing they can see is the thing they'll call the router.
Yeah. Because a label machine to do that is like, what, $50 off Amazon or whatever?
Less. I have two, because if one dies, I'm just going to use the other one, not go find batteries.
I also have two. There's a Brother P-Touch PTD200G, and that generally runs about $30. You can get that at Walmart. You can get it on Amazon, what have you. I do strongly recommend the Brother P-Touch label makers. I've used considerably more expensive ones, and I've liked them considerably less.
And even going so far as to label important cables. Because, if you want to make sure that the internet cable is actually plugged into the router and hasn't fallen out or something, having the label on that can also help. Even sometimes in the PDU, we'd label the power connectors so that if you have to pull both power supplies for prod 02, you can know which power cable it is without tracing each of the power cables yourself when you're trying to do something in a hurry.
So this was a ton of fun, everybody, but it kind of felt like sort of an unfocused fishing expedition, and I'm not sure that we really hit any particular question that David or anybody else might have had. So if there's something more specific you'd like to know about a particular aspect of managing servers, we'd love to hear from you.
Yeah, show@2.5admins.com. Right, well, we'd better get out of here then. You can find me at joelrest.com/mastodon.
You can find me at jrs-s.net/social.
And I'm at Allan Jude.
We'll see you next week.